joining. It's a pleasure to be speaking at MindHack. And what I wanted to do in the next 30 or 40 minutes is just give you a little bit of an introduction to the history of the IBM AI story, what we've done at IBM around AI and our Watson technology, which began as this Jeopardy winning supercomputer in 2011, and how we grew that into really $1 billion scale business. So maybe I suspect some of the other sessions at the conference this week will be talking about technology. In this session, I'm going to give you a bit of a glimpse into the business side and how we grew this business, and hopefully a bit of insight for you on what AI can do, how AI has evolved, but also the business of it, how you actually build a business around AI. So let's jump into it. And for IBM, this pivotal moment happened on February 14th, 2011, when the Watson supercomputer competed in the Jeopardy game against two of the most winning competitors in the history of Jeopardy. So let's have a look at how we created this technology, a journey that began way back in the mid-50s until 2011. Then we'll talk about the art of the possible 2011 to 2014, how we turned that into a business in the early years, 2014 to 16, the marketing, the expansion of this into a real business, and some of the lessons that I think we learned along the way that can be useful to you as you think about AI and what you can do with AI and how you might one day start your own business around AI or perhaps other technologies. So let's begin at the start of it all in the 1950s. I think, as many of you know, the first electronic computers were built at the end of World War II. The ENIAC computer is generally considered to be the first electronic computer. But as soon as computers were invented, almost like the same day, people began thinking about how to do AI. They didn't necessarily use that terminology, but this idea of can we get computers to think was almost immediately something that people began working on. Now, some of you may recognize this man in the photo, but if you don't, let me introduce you to him. His name is Arthur Samuel. He's one of the early seminal thinkers of AI. And he was a research scientist at IBM in the mid-50s. I have no idea what they actually paid him for, but what he became famous for was his dream. He had a dream to create a computer system that could play checkers. Now you may say, well, who cares about checkers? I mean, what's that got to do with me? That's so unimportant, that's so trivial. But actually, his dream was a little different. He didn't want to create a system that played checkers or that only played checkers. He wanted to create a system that learned from experience. Every time it played checkers, it got a little better. He would come into work and play games with it over and over again. In fact, at one point, he even programmed it to compete against itself. So it began to learn not at the pace of human interaction, but the pace of machine interaction. In 1959, he coins the phrase machine learning. In 1962, he pits his machine learning checkers game against a regional state champion, a guy by the name of Robert Neely, and the machine wins. Now, probably nobody noticed it at the time, but we can look back with the hindsight of 2020 vision and recognize that was actually probably a pivotal day in the history of the world, where a computer system, a machine learning computer system, beat a human expert in a challenge of strategy and intellect. So Arthur Samuel's kicking this all off at IBM. He was one of many seminal thinkers like Alan Turing, Herbert Simon, Alan Newell, Marvin Minsky, all the great seminal thinkers of AI at that time. Now let's fast forward to the mid-80s, and IBM takes on another great AI challenge. The challenge to create a supercomputer that can beat the world's greatest minds at chess, a system that you may all be familiar with called Deep Blue. And in fact, the first challenge of Deep Blue, we didn't win. The IBM computer did not have a decisive victory. It came back with an even stronger computer in 1997. And on May 11th, 1997, this new supercomputer Deep Blue beat the world reigning chess champion Garry Kasparov in a 6-game match. It was a massive computer. It was very powerful, really a very large cluster that they had to haul in. You can see the photo of it here in the pictures. It fills up half a room. But it did something that had never been done before, which is to beat a reigning chess grandmaster. That was 1997. Now, after that, IBM researchers began wondering what should be our next grand challenge in AI. And as strange as it may sound, it began with a few IBMers from our research division sitting in a restaurant. The man here that you see is Charles Lickle. I actually met him a couple of times in my career at IBM. And in 2004, Charles and some colleagues were in a restaurant in Fishtail, New York. And they were in this restaurant. There's like a main area of the restaurant where people order meals. And in the back of the restaurant, there's a bar with a sports TV. And all of a sudden, in the middle of the meal, the whole restaurant goes quiet. And Charles is wondering what just happened? Where'd everybody go? And he realizes that they've all left the restaurant and gone to huddle around the television. Because playing on the television is the Jeopardy game with Ken Jennings, the winningest player in the history of Jeopardy, which had been playing on the television since 1964. And he was just stunned by this, and he began to wonder, could IBM create an AI system that could play Jeopardy? So Charles goes back to IBM and he begins discussing this idea with Paul Horn, who was then one of our leaders in the research division. And they start looking for people to put together a research team on this project, which they do in early 2005. Now it's a small research effort, but they're passionate and they stay at it for a few years. Now, what makes Jeopardy so particularly difficult is, unlike other games of, trivia, excuse me, in Jeopardy, you don't have to guess the answer. You have to figure out the question. In the game of Jeopardy, you're given the answer and you have to ask the question. So the answer may be, Ottawa, and the question might be, what is the capital of Canada? So it's actually a big inversion of thinking, and in order to play this game, you not only have to do that inversion of thinking, you not only have to know all these facts, but you have to formulate the language of the answer, which was very difficult for computers in those times. So Jeopardy is super hard, but they put together the Watson supercomputer to do this, and in training it, it consumed over 200 million pages of data to compile enough trivia and understanding of language to play the game. They competed against the two most prolific winners in the history of the game, and the computer won. The computer won with a very impressive set of hardware and going along with the software. And I've put the specs at the bottom here. You can see close to 3,000 hardware threads, CPU threads, 16 terabytes of RAM being used against these two humans, these two poor humans. They probably didn't have a chance. But this is 2011. So one of the things that's important is they started on the research effort in 2005. It was not until 6 years later, in 2011, that they were ready to go against some of the most stellar human beings on the planet. Now, at that time, after the spectacular win of Jeopardy, IBM gets very excited, and they're like, "Wow, we're really on to something." So they decide that they want to turn this into some kind of a business, not just a game show marketing event. And don't kid yourself, until this point, it's a research project. It's good from an academic sense, it's good from a scientific sense, and it's good for marketing. But it's not useful for helping anybody in the real world. So they want to now pivot from science and marketing to real world benefit. And one of the things they're worried about is that the whole term of AI is scary. It's scary. Whenever you say AI, people in that era, in the 2011, 2012 timeframe, people associate AI with Terminator. I think it's like the end of the world, right? And IBM didn't want to be associated with such a negative sentiment. Now, it sounds strange to us today, because today that's sort of passé. Nobody really thinks about AI and as such a scary thing. But at the time, it was a real concern. So IBM coins the phrase cognitive computing to move away from the scariness of AI and embrace a language that hopefully people will understand its true intent which is to be a little bit more intelligent and more helpful in the world of business. And in 2014, after a few years of engaging with customers through service engagements and discussing what can be the art of the possible, in 2014, IBM launches the Watson Business Unit as its spearhead for cognitive computing. And it launches 2 products that year. One was the Watson Engagement Advisor, which was a natural language chatbot, bringing the best of IBM's Watson, the Watson natural language processing to a chatbot interface. And the second was called Watson Explorer, which was doing AI natural language analytics on large corpuses of text. And that evolved into what we call Watson Discovery. And you can see Watson Assistant, which is the current chatbot, and Watson Discovery, which are current technology for analyzing large corpuses of text. You can find both of those as very active products today. But that's really just 2014, only 6 years ago. And that's the start. Now, things ramp up quite a bit in 2015. They do 3 big things. Number one, they start reaching out in the education space, first on the university campuses, with university and academic programs for both students and professors. And they start launching a whole array of courses for continuous learners on Coursera. And you can see some of the courses here on the right-hand side of the slide. So that's on the academic front. They begin to broaden out of the natural language processing domain that we had with the first 2 products, and they launch a whole new unit called Watson Health to engage on healthcare and working on, cancer research and other things. And thirdly, they begin to expand on the business front and launch a With Watson partnership program to encourage other companies to build their applications with Watson componentry. Now, as we get into the end of 2015 and early 2016, IBM begins to take this natural language processing, which is really its crown jewel coming out of the Jeopardy research, and it launches several services on the public cloud. So we're now going from products, a couple of products that you can use, to an array of cloud services for natural language, speech to text, text to speech, natural language understanding, language translation, language classifier, personality insights, tone analyzer. All these things start to go live as services on the public cloud that you can code to. You can actually code to these through an API. So we're working hard to attract a developer audience. As we get into 2016, another big change happens, and IBM acquires the weather company. And you say, why would IBM acquire the weather company? IBM's a company that deals with banks and insurance companies and logistics companies, and what do we have to do with the weather? Weather is super important because weather affects everything. Weather affects travel, weather affects business, and so it becomes a very important input to so much of the AI that we do. And that was one of the big things that IBM was after, was to get a sort of a capture this dynamic data that's so important for AI. And that year they announced that they will infuse the weather company forecasting with AI technology from Watson. Now the research continues, and it's very well funded because of all the excitement, and the research continues off in many very dynamic directions. One of the interesting projects that comes along is using AI for culinary innovation, and you can actually buy this book on Amazon, I believe, Cognitive Cooking with Chef Watson. Now, Chef Watson was an interesting idea. Chef Watson was the idea that AI can actually invent new recipes. That doesn't sound so hard. You take a recipe from one book, you take a recipe from another book, you kind of mix and match, maybe you get a new recipe. No. Don't be confused. That is not at all what Chef Watson is doing. What Chef Watson was actually doing was looking at the chemical compositions of different foods and learning what chemicals will taste good with other chemicals based on the chemical structure, based on the texture. And from that, it was able to create entirely new recipes that nobody had ever dreamed of, putting combinations of food together that nobody would have ever thought of. So it was really quite a clever idea. Clever idea, not necessarily the next billion-dollar business idea, but a fascinating example of what AI can do. Now, as we get into 2016 and 2017, IBM's got all this work going on for natural language processing and for health and for weather, and it starts to realize that there is demand and a need to provide tooling for people to create their own AI. It's not enough for us to build AI inside of IBM. People want to build their own AI. So we launch a platform of tools that we call the Watson tools, or Watson Studio is really the main tool. Watson Machine Learning is the back end behind Watson Studio. And later, a couple of years later, we launched Watson OpenScale behind that. The Watson Studio, which is the front end of all this, is the IDE. It's the developer interface to a whole array of development tools for building your own AI, building models, training models, hyperparameter tuning, and eventually deployment. And this goes live first on the cloud. It was originally marketed as Data Science Experience, then later renamed as Watson Studio. And today, it's available on the public cloud, private clouds, and desktop options as well. Now, an interesting point I want to make around the tooling for AI is, you have a look at this chart. What you see on the left-hand side is growth in the Apache Foundation code for analytics, data ops, and machine learning. On the right-hand side, you see the IDC's estimate for the growth in AI business. And what's fascinating about this is, they're not perfectly correlated, but they're pretty closely correlated. And that's not a coincidence. Now, correlation does not imply causality, but I'm pretty confident that the growth that we see in AI is an unprecedented growth. There's never been anything like it in computer science over the last 50 years. No domain of computer science has grown this fast. And I believe the reason that AI is growing as fast as it is because so much of it is based and is building on open source. We move fast, we move fastest as a community when we work together. And the model that we have for working together, for sharing in computer science, in programming and development and machine learning, is open source. So the growth you see on the left and the growth you see on the right are correlated. It's not by accident, because what's happening on the right, that growth is depending really necessarily on the availability of rich open source componentry for machine learning and AI. And so recognizing that, when we built Watson Studio, we really built it fundamentally. It's built on open source, and it's built to provide open source. So when you use Watson Studio, you're getting, Jupyter Notebooks and RStudio and Spark and all the major componentry that you know and love and want to use. Now, also at this time, we're now into 2016, 2017, we started exploring other creative uses of AI, which we branded as Watson. One of them was the very interesting idea of using AI for fashion design. And here you can see the Czechoslovakian model, Karolina Kurkova, and her AI design dress, which she wore to the Met Gala in 2016. That was one particular engagement that we did with a British design studio, Marchesa, and that trend continued. And we also did partnerships with Jason Gretsch in Melbourne, Australia. And you can see some of the dresses and designs that came out of that engagement. So you'll notice a few things happening over these years from 2014 when we launched the division until now. We're expanding from natural language processing. We're engaging in exploratory science and marketing. But there's something else that's going on, which is we're moving from products to a brand. Watson no longer is only the Jeopardy playing computer. It's also, now it's a brand that includes all kinds of things beyond the Jeopardy technology for natural language processing. In 2018, we take another very important leap into exploring pioneering trust in AI. How do you know you can trust AI? Customers are telling us, they're asking us, this Watson stuff sounds good. How do I know I can trust it? Maybe it's biased. I can't have technology that's biased against people, against products, against populations. Prove to me it's not biased. How do I know the AI isn't going to drift? The models aren't going to drift from the data. Prove to me that it's not drifting. And how can I understand why AI is making the decisions that it's making? Let me explain why that's so important. Let's say you were to use an AI system to help automate a loan decision. You know, which customer should get a loan, should be accepted for a loan, which customer should be rejected for a loan. Well, if a customer is rejected for a loan application because of a decision that the AI made, and that customer comes back complaining or asking, why was I rejected? You're going to need to know what to say. You're going to need to explain it to them. So it's very important to explain the decisions that AI makes if we're going to start using it in a real world context. It's going to start affecting decisions, business decisions, and people's lives. So this is the pioneering work that we did at IBM to detect bias, to detect drift, and to provide explainability around the major models of AI. Now that went to market as OpenScale, but as we looked at it, we thought to ourselves, you know, this is too important for IBM to own this alone. So we also brought it to the world as open source, and we delivered the fundamental algorithms of AI trust for explainability and fairness and so on. We brought all that to the market as open source. So you can now, anyone can go and download for free the source code and the algorithms for AI fairness, the AI Fairness 360 Toolkit, the AI Explainability 360 Toolkit, the Adversarial Robustness 360 Toolkit, and so on. And also around that time, in the 2018 period, we were hired by a company called Daub to see if we could use AI to create new perfumes. I mentioned that these are just some of the wild, business applications of AI, but it's fascinating to see the history of it. And you look at this, you go like, what? Like, who cares? Like, why do we need AI to do this? But I was privileged to meet the researcher who worked on this. And he actually showed us samples of the perfumes. I don't know anything about perfumes, but I can tell you I was blown away. I was just totally blown away by it. Really the most magnificent scent I've ever probably smelled in my life. And he said the genius of the whole thing was this. What we normal people don't realize about perfumes is that there are perfumes that are made with low-cost ingredients. There are perfumes that are made with higher-cost ingredients. There are perfumes that are made with very rare, like very hard to get your hands on ingredients. And obviously they cost more and more. What the AI was able to figure out that no human being had ever figured out was that if it cut back on some of the cheaper ingredients, it could actually use a little bit of the more expensive ingredients and keep the total cost in the medium range. So you're getting high cost ingredients, medium cost on the total composition, and you can sell this perfume at the medium range with qualities that have never been sold at the medium range, because you're now able to include some of the high cost componentry. So, really fascinating stuff. And that, on the one, this one, feels a little bit like a marketing event, but actually it was commercialized and it was an actual customer engagement that resulted in product. A couple of other examples that are a little more current. So let's go into then now the 2018 to the 2020 time period. Project Debater, a fascinating technology out of our IBM research group, an AI system that can actually debate with human beings on topics of serious social consequence, not just tell you what the weather is. Think about it. You don't need an AI system to tell you what the weather is. You can just look out your window, you'll know what the weather is. But imagine an AI that can debate with you on serious issues. And the Project Debater technology actually only needs about 15 minutes to prepare on a new topic. 15 minutes and it's good to go against world-class debaters. If you go onto YouTube, you can see several debates between Project Debater and world-class debaters on a number of different topics. So this is very impressive technology, and it's been evolving over the last couple of years. You've probably also, or you may have heard of, or may have seen the IBM Watson technology in action at the US Open just a couple of weeks ago, where it was answering questions like, what was the greatest tennis rivalry of all time? And just this month, we're using it again on the Intelligence Squared That's Debatable TV program, where different social topics are being debated, and the Watson technology is being used to synthesize opinions from thousands of viewers who are writing in with their comments and their opinions on the debate topics. Watson is aggregating thousands of opinions on either side of the debate, and summarizing them, and that summary is being shown as part of the debate process on the TV show. Those just are some very recent examples. We also just announced that we're using Watson as part of our ESPN Fantasy Football initiative, and Watson's going to be used to provide trade assistance for players and player insights, so be better equipped with AI to decide who to trade and when to trade. So these are fun examples. They're fun examples. They capture the imagination. But on the business side, what started as this jeopardy technology and grew into the natural language processing with chatbots and document analytics. And then we added on to that the tools for building your own AI. And then we went on beyond that to start building many different vertical applications that are building on those technologies. And just have a look at this top row: document processing, customer care, manufacturing, human resources, workplace automation, healthcare and genomics, robotic process automation, cybersecurity, worker safety, fraud detection, supply chain analytics, weather predictions, advertising, IT automation. There is no other company in the world that has this range of AI-infused technology. And it all started with that Jeopardy game. And a lot of it, not all of it, a lot of it is based on natural language processing, and another wave of it is based on more classical machine learning techniques. Now, not everything we did was so successful. We had some great ideas that they were great. They're great ideas. On paper, they look like good businesses, and probably, perhaps if they were created by another company, they would have been more successful. But I want to mention these in the spirit of learning. One of the very interesting ideas that we had in the early days of Watson was to partner with a lot of the early childhood education organizations, such as Sesame Street, and try to reinvent how we do children's education with Watson. It was a beautiful idea. I mean, a really beautiful idea, and a way of doing something constructive for the world. But IBM wasn't necessarily the perfect company to turn that into a billion-dollar business. Our history, our channels, our marketing, everything about us is Fortune 500. So it was venturing into a neighborhood that we were a little bit unfamiliar with. And similarly, we had a great business idea around client insights for wealth management. Great idea, and I'm sure there are lots of companies that could turn this into a fantastic business. It's a little bit outside of our comfort zone for IBM. Again, we deal more with large corporations, a little bit less with individuals, individual brokers, and individual accounts. So I want to pivot now to some of the conclusions. First of all, this AI stuff is not magic. It's computer science, but it's very, very different, a different kind of computer science to what we've been doing for the last 50 years. It's a whole class of algorithms that learn from experience. They learn from digital data. And so they give us a certain power that we didn't have in the past. For the past 50 years, if you're a programmer, you had to programming everything by hand. If, then, else, call this function, call that function, case switch. You were always limited for the past 50 years. You were limited by the ability of the programmer to express logic. Suddenly, in the era of AI, we have a new approach, which is it's not only about what the programmer can express in logic, it's also about what the machine learning can infer from the examples that are present in digital data. And with that power at IBM, we're helping lots of companies solve real business problems with the Watson technology, which that began all those years ago in 2011, or really before that in 2005 when the research project started with the Jeopardy technology. All right, so let me share with you 8 lessons that I think will be interesting for you to think about as you, if you're interested in pursuing your own business. And if you're not interested in pursuing your own business, you may still find this interesting, just as an educational exercise. So 8 lessons from all of this history. Number 1, be prepared. Anytime you want to do something dramatic, be prepared for a long run, a long marathon. Just look at this history. We started in 2005 with a research effort. It took us 6 years just to get to the Jeopardy game. And that's all, we're just spending money. There's no money being earned from that. In 2011, 2014, we're trying to figure out how to start a business. We're doing individual engagements with individual companies. Can we help you? Can we give you some scientists? Can we jointly work on something? But we don't have any products. In 2014, we start delivering the very first products. And from 2015 to 2020, that's where we're growing the business. So you look at that, it's 15 years. That's a long time. So if you're looking for a quick fix, looking to become a billionaire overnight, high tech's not the place. Number two, you want to build $1 billion business? It's going to cost you time, it's going to cost you money. Okay, go big or go home. IBM went big on this. We went big. We could have got burned by it. We're fortunate that we were very deliberate in how we did it, which mitigated our risk. But be prepared to go big. There's no easy wins in life. Number three, it's not just a long time to be successful. It may be a very long time to get to profitability. By the way, just because you're earning money doesn't mean you're profitable. So have a look at Uber. Uber is a great example because, we all know Uber. So I just use that as an example. There are many, many, many other startup examples that are follow exactly this pattern. Uber started in 2009. 10 years later, when the whole world is using them, approximately the most popular business app on the planet, they lost $8.5 billion. They lost $8.5 billion in 2019 after 10 years. And they're very, very popular. So think about that. You got to be willing to bear with that loss. It takes tremendous fortitude of the developers, of the investors to stick with it. Number four, there will be misses, just as IBM missed on a few of our products. That's okay. Misses are okay. Misses means you're stretching, you're trying. If you're not missing, it means you're probably not trying very hard. If everything you do is a big success, well, imagine what you could do if you just pushed yourself a bit. So it's good to have some failures. Failures mean you're pushing it. You're pushing the limits. Don't be afraid to fail. The trick is when you fail, you got to fail fast. Something's not working out, fail fast because you don't want to keep pouring bad money in or good money after a bad idea, I should say. Point number 5 is avoid over-promising. I think one of the things that, if we had to do it again at IBM, everything we've done with Watson, actually, it's quite successful. But the hype got out of control. People thought, we'd be curing cancer and, having robots running the world in no time. I think it wasn't, in many cases, it wasn't even anything that we did or said. It was just the illusion was so compelling. The illusion of Watson winning the Jeopardy game was so inspiring that, passions ran very high. We probably should have done more to mitigate the hype. It's better to undercommit and over-deliver. Okay, don't let the passion get too high. All right, and last 3 points. Number 6, Watson became successful. Part of the reason that Watson became successful and grew into this, this technology, a set of technologies that will earn billions of dollars a year, is because it was a brand for AI. It wasn't one product. If we had limited our energy to one product for AI, it would never have amounted to a fraction of what it is today. And that one product would always be at tremendous risk of some competitor doing something better. Some other large company or a small company with a good idea. Part of the reason that we're successful is we have a certain breadth, and that gives us a certain safety. Even if 1 or 2 products get knocked out, we got lots more that are running. Number 7, the products alone were not enough. You want to start a business, it's not only about technology. We started business programs to engage with independent software vendors so people could start using our components. We ran marketing events to showcase the boring practical business technology, but also the fun stuff, that I showed you earlier. We ran academic programs to reach out to students and professors, and we provided both paid and free services to help our customers use the technology. There's a lot you have to do to set up a business and get it running. It's far, far more than just the actual engineering work. And the last point I'll make is we're able to move fast because we embraced open source. Even on a 10-year journey, if we hadn't embraced open source, this would have probably taken us 30 years to get where we are today. So I would encourage everybody to think about that. There is this fine balance between creating something new and also embracing the community. It's a fine balance. Try to be responsible in doing so. You want to be a good citizen in the community and give back. You want to consume and give back, but you also need your own secret sauce. We've tried to strike that balance responsibly in IBM. So hopefully some of those thoughts are of use to you. I just want to conclude with one final point on where this is all going. If you look at the arc of history, of computing history, 1970s was really the era of mainframes. And, we don't talk about mainframes so much anymore, but actually something like 75 to 80% of all credit card transactions still at some point in their resolution flow through a mainframe computer. So don't kid yourself, the world is still running on the shoulders of mainframes. But that was the era of transaction processing, and the mainframe remains today the backbone of most transaction processing in the world. The 1980s and 90s saw the PC era where everybody started to get, computers of their own, servers that you can put inside of a building. Everything started to get interconnected with intranets and the internet. And the developer community grew to about to 1 million developers. Then the era that we're just finishing now from 2000 to 2020 was the era of mobile and cloud. And that saw the growth of the developer community to about 10 million developers worldwide. The next generation, the era that we're entering, the era of intelligence, the era of AI, is going to see another order of magnitude growth in opportunity for developers. And when I say developers, I'm including data scientists in that, the people who build AI. This is a tremendous opportunity, a tremendous time of growth. It may not be obvious to us right now, but we'll look back at this era 20 years, 30 years from now, and we'll go, wow, how the world changed because of what we did. So let's wield that responsibility with care. Let's embrace it for fun and for hopefully some good economic value as well. Okay, if you want to learn more about what we've done at IBM with AI, I would encourage you to go to any one of these three sites, IBM.com Artificial Intelligence, IBM.com Watson, or www.research.ibm.com Artificial Intelligence. All three of those have very interesting different angles on what we're doing.